Okay, this is the Chapter 11 Algebra Review, Graphing Lines Continued, and so I wanted to do some more problems. If you have gotten through 1 through 20, that's great. I hope you can get through all of it. These are to help you if you can't. If you just have been through Algebra 1 and you're struggling with the rest of them, I can, you could do it, and I'm hoping you can watch these and it'll help you. Let's say that I have these 2 points that are on a line they give me. They want me to graph the line. Well, I'm just going to do a little graph over here. No, I don't know the slope, but I don't need it, do I? Because I have 2 points. This is the x-axis. Here's the y-axis. 0, negative 2 would be right here. And 1, 3 would be right here. Okay. So I can graph my line. It's right here. One thing I know they're probably going to ask me the slope in a minute, and that is the next question, what is the slope? I could do 2 things. I could count it off. I could say, now this would be easier to count had I had a grid that had lines on it, but if I just want to even count up with what I have here, I'm going to rise 1, 2, 3, 4, 5. So my rise is 5 from point to point, and my run is 1. So my slope is 5. Now I could count it off. That's one way to get it. Another way to get it is to use the slope formula. And I'm going to remind you that there is an easy way to use the slope formula. I could say the slope is subtract my 2 y's on top. I could write that as change in y if I wanted to, and subtract my x's on bottom, which I could write as the change in x. That's just all that means, that you're subtracting 2 things. I could label this and say, ooh, this is my first point, so this is the x of my first point, and this is the y of my first point. And ooh, b is my second point, so this is the x of the second point, and this is the y of the second point, okay? And I could plug them in, and I'll do that, and I want to show you a couple different ways to get it. So I could say 3 minus 2. You might want to put parentheses here after the subtraction sign, and 1 minus 0, just because a lot of people will forget to put, like if there's 2 negatives, they'll think they only need to write 1 for some reason. But remember, the formula has a subtraction sign, and the y1 up here was negative, so this actually becomes 3 minus 2 becomes 3 plus 2, which is 5 over 1, and we get 5 also. Another way to do it is the point, you can call this is like some teacher made this up, and I liked it when they showed it to me. It's called stacking the points and subtracting. I got to subtract the x's and y's. So I know my slope is change in y over change in x. So what I could do is write my points down, and I'm going to choose the point B to go on top just because some of the numbers are bigger, so I kind of look to see which point has more bigger numbers in it, okay? And I'm going to subtract here. Now the y's get subtracted and go on top of this fraction that I'm making over here, so I'll do those first. Here's my x's, here's my y's. Points are always in alphabetical order. Rise over run's kind of opposite because you go up y and over x. And remember, that's the change in y over change of x. That's why people get confused about points and slope, is because they're kind of backwards, aren't they? Slopes are written x first, then the y. But when you count off slope, it's you do the y's first, then you do the x's. And so that's why you get confused sometimes. All right, so I'm going to subtract my y's now and get on with it. 3 minus 2 would be 3 plus 2 would be 5. And then if I'm going to subtract my x's now, 1 minus 0 is 1. Sometimes when you put things in a vertical form, it's easier to see. I still am getting the slope of 5 no matter what I do. So you've got multiple ways to do it, and you can just kind of pick what works best for you, and sometimes different things work in different problems. If you have a graph, it's easy to count it. If you don't have a graph, you might want to use one of these other methods. 23 says use the coordinates of point B, which is B is 1, 3, to write an equation of the line in point-slope form. Okay, point-slope form is that form that I told you we use in calculus, and it's y minus y1 is mx minus x1. The things I need to plug in are the slope. Well, I know that. That's 5. Okay, so I'll put that in here. I always want a plain old x and y in every equation, so I always leave those, and I know that used to confuse me. I got a subtraction sign. I'm going to write it down both places. Now I'm going to look. What's my x value here? Remember, this is x1, y1. It's the x of my 1 point and the y of my 1 point. My x is 1. and my y is 3. All I need to do now is just close this parentheses here, and I've got my answer to number 23. This is that formula in points slope form. Now, on 24, they asked me to transform it into slope-intercept form. Slope-intercept form is y equal mx plus b. And if you remember, how I get it in that form is I solve for y. That's basically, if they just told you solve for y, and you simplify everything, you do get this form. So what I'm going to do is this. I'm going to say, take this equation, and I'm going to solve for y. Before I move that 3 to get it away from the y, because that's what I want by itself, I'm going to simplify the right-hand side by distributing. That would be 5x plus 5. Now I can solve for y by adding 3 to both sides. That would cancel out, and I'd get y equal 5x, and 5 plus 3 is 8. All right, so I have y equal 5x. Y equal 5x plus 8. That's the slope-intercept form. The slope is 5. I see it right here. And remember this 8 on the end, that's my y-intercept. Okay, so problem number 25 says, write an equation for the line in the form of ax plus by equals c, in which a is greater than 0. What is this talking about? This is talking about that we don't want a to be negative. A needs to be positive, and I had mentioned that in a previous video. Wow. Okay. So if you look at this, this is again, if you remember what this is called standard form. We've already used it in Algebra 1, and if you've taken Algebra 2, we've used it there also. And what that means is we're going to put the x's and the y's on one side, and we're going to make them we don't want any fractions in the first term, the x term. Its coefficient needs to be positive. Well, here's what I have right now. Okay, so let me move the x to be over there with the y, because we always get them on the same side, and then you leave your number on the right-hand side. Okay, so that would add up to 0 on that side. On the right-hand side now I just have 8. And I always write the x term first, and that's a positive y, and I'm adding them together, so it will be negative 5x plus y. Now, this would be fine, except that the a term is negative. The coefficient of my x term right here is negative. And I need it to be positive because that's just proper math communication. It's kind of like protocol, if you want to say. This is how we politely communicate with one another. So how am I going to do that? Well, what I can do is just multiply both sides by -1. If I do the same thing to both sides, I keep my equations equal. I keep them balanced. So this is going to be -1 times -5x is a positive 5x. -1 times y is minus y, okay? And then 8 times -1 is -8. That's all I have to do to change it over. Notice what I could have done is this. When I multiply by a -1, doesn't it just change the signs on every single term? So if you know that and you know you need to multiply by -1, you could just switch the signs on every term and just write on the next line, write it down with all the signs changed on every single term. This is my answer to 25. So that's complete. Do as much as I can on the next one and see what I can fit on this video. This is problem number 26, and it's talking about the equation 4x minus 3y is 0. This is already in standard form, isn't it? It's got the x's and y's on one side. There's no fractions. The x is positive. All is good with the world. They want us to put it in slope-intercept form on 26. So that means slope-intercept form means solve for y. That's what puts it in slope-intercept form. Well, if I want to get the y by itself, maybe I want to move the x to the other side. I could also, if I do that, let me do that just because some of you do that and then you don't know what to do with the negatives. Another way I could have done it was just to add 3y to both sides. That would put the y by itself. But let me just do what a lot of people do, and they just because that seems the first thing that comes to mind. If I move the x to the other side, I have negative 3y is equal to negative x. All right, I want to get y by itself. So what I'm going to do to get y by itself is -3 and y are multiplied. When they're smushed together like that, remember that just means -3 times y. The opposite of multiplying by -3 is dividing by -3. A negative over a negative is a positive, and I would get y equal x over 3. I could also write that, if I wanted to, as 1/3, because there's an invisible 1 in front of the x, 1/3 x. Okay, so that's what they wanted me to do on 26. Let me draw a little line here. That is slope-intercept form. By the way, what is the y-intercept here? Well, there's no number on the end, but couldn't I write this as plus 0 if I wanted to, and it would be the same value? So my y-intercept here is 0. Okay, and that's actually what 27 is asking me. What's the slope? Well, the slope is the number in front of the x. It is 1/3. And the y-intercept, since it's missing, we could just say, well, 1/3 x is the same thing as 1/3 x plus 0. Now there's a number on the end. The number is 0. So they want us to sketch a graph of this. And there's something interesting that happens when the y-intercept is 0. So let's look at this for a minute. If the y-intercept is 0, that means my starting point when I graph is 0. So let me choose a color to graph in. So that means my first point is 0. There is a number there. The lazy mathematician just didn't write it down because he didn't think he needed to. He didn't know you were going to get confused when you were graphing. He didn't think of that when he started that little fad that stuck, okay? So now I've got my starting point. It is 0. And I'm going to count my rise over run. Rise 1, run 3. Rise 1, run 3, okay? So I could get my line. It looks like this. It goes through the origin. And you know what? These kind of lines that go through the origin, they have a special name. They're called direct variation because the y and the x vary directly with one another. As a matter of fact, if you look at this over here in this form, it looks like something we could do with a proportion. And proportions, they all end up graphing out like this, which is kind of cool. All right, let's go here. That would be great. 29 says, what's the x-intercept? Well, we had this right here. Remember, the x-intercept means the opposite variable is 0. So if I want the x-intercept, y is 0. So we could plug it in. 0 is 1/3 x. If I want to get x by itself, I need to get rid of the 1/3. I could divide by it, but it would be easier to multiply by the reciprocal. 3 times 0 is 0. These cancel out. X is 0. And we could see that from the graph. We see that both the x-intercept is 0 and the y-intercept. So let's see. Let the point that is on the line, whose x-coordinate is -3, so A is going to be the point, x is -3, and we don't know the y that goes with it yet. We could go find it because we got the equation. Let me do that in a different color. So coming over here to see, okay, here's my equation. X is -3. This was the equation I plugged it into. This equation right here, in case you're lost. 1/3 times -3 is -1. Okay, so A is -1, and B is the point on the line whose y coordinate is 4. So this time y is 4. Let me do that in a different color. I want to use that equation and plug in y is 4. 4 is equal to 1/3 x. To get rid of the 1/3, I'm going to multiply both sides by 3. So 12 is x. Okay, so there's the 12. What is the distance between A and B? Okay, if I had a graph, I could use the Pythagorean theorem. I don't have a graph, so I'm just going to do this. Remember, it's the difference of the x's squared plus the difference of the y squared. You may have to go back in your notes for that formula. I'm running out of time on the video. That's why I'm talking so fast. So if I subtract the x's, it's 12 minus -3, which is 15 squared, plus 4 minus -1, which is 5 squared. And if I total that up, 15 squared is 225. 5 squared is 25. That would be the square root of 250. And that would be 25 times 10. If I reduce that radical, it would end up being 5 square roots of 10.